So I hope you are enjoying the videos on limit of a function. And finally, we are at continuity. So we talked about a lot, and now we want to talk about continuity. Now, continuity is basically based on whatever we've learned. So here we are assuming that a function f is continuous at x is equal to a if three condition holds. So let's look at this three conditions that we need to learn from here. So one, if the function is continuous, then when I plug in a, I should get it must exist. So f of a must exist, right? So if the function is continuous, then when I just plug it in like doing polynomial function, like direct substitution, I should be getting a value. It must exist. Two, then limit as x is approaching a of f of x must also exist because it's continuous. This implies that limit as x is approaching a from the left of f of x is the same as limit as x is approaching a from the positive of f of x. So these are kind of like two-sided, and this is one-sided, forming this one. Then continuity is in such a way that if this one is true and this one is also true, then for us to say that indeed f is continuous, then the last property holds. What's the last property here? Limit as x is approaching a of f of a, that is the two here, should be the same as f of a, which is the one here. So that is continuity, right? This is basically what we just need to talk about, continuity here. So we need to have this in mind anytime we are working with continuity. Then if a function is not continuous at a, then the function is said to be discontinuous at what? A. Then it means that any of the property here does not, if does not hold, then it means that it is not true. So one, we can say that f of a does not exist, right? And we can talk about limit x is approaching a of f of x also does not exist. This might imply that limit x is approaching a from the left of f of x is not the same as limit x is approaching a of f of x from positive. And then another one that can also happen is the first one can be true, the second one can be true, but they are not the same. So when you are talking about discontinuity, this is how it's supposed to be. If any one of this is not true, then it is not continuous. So let's assume that I start and I just plug it in, and this is giving me nothing, like it does not exist. Then I can conclude that f is discontinuous. But let's assume that this is right, and I come here and this is also does not exist. Then I can base on this one to say that it does not exist, right? But let's assume that this is true and this is also true. We cannot say that it continues unless this and this are the same. So if they are not also the same, then the function is also discontinuous. So basically, these are the things that we need to learn under continuity and discontinuity. So now let's note. So these are just what we just learned. We are saying that f is continuous at x is equal to a if this one exists. And then if this one exists, then the positive is the same as the negative. And then these two should be the same. So that's what we are going to use to solve our functions here anytime the question is talking about continuity. So first, the question is, we are given this and the question is asked, does this exist? So let's go to continuity. For this to be in existence, the left and then the right should be the same, right? The right and the left should be the same. So for us to conclude on this, we need to find left and then the right. So let's do so. Limit as x is approaching -1 from the left of f of x, and we need to also conclude on limit as x is approaching -1 from the positive of f of x. But what is this function? Let's see if we can simplify f of x, because we are picking limit. Okay, yeah, so let me just do it here. So limit x is approaching -1 from the left, x squared minus 1 divided by 2x plus 2. So here I'm going to set x is equal to -1 and plug it in. But when I do that, the denominator will be 0. So as we talked about rational function with limit, we need to simplify. So let's try and simplify. This is limit x is approaching -1 from the left. X squared minus 1 is difference of 2 squares. So this is kind of x plus 1, x minus 1. The denominator too, I can factor 2 out and then have x plus 1. So now I see that this will cancel this. And I'm going to have limit x is approaching -1 from the negative, and this one will be x minus 1 divided by 2. So now let's plug in the minus. So I'm setting here, we set x equal to -1, and we are going to have -1 minus 1 divided by 2 minus 2 divided by 2, and this is going to be -1. This is going to give us -1. So the left side is going to give us -1. So let me just write this one somewhere here and just see that this is going to be -1. Now let's go to the right side too as well. So the right side also goes through the same process, right? So the right side, this is also the same as limit x approaching -1 from the positive, x squared minus 1 divided by 2x plus 2. Right? So we go through the same process. So basically the idea here is that anytime we are dealing with the left and the right and they are using the same functions, basically it's kind of the same. So this is going to give us something like this. The same thing, difference of 2 squares here. So limit x is approaching -1 from the positive, x plus 1, x minus 1 divided by x plus 1 times 2. This cancel this and we get the same thing as we had from the first one. And this is x minus 1 divided by 2. And same thing, set s equal to -1. And -1 minus 1 divided by 2 minus 2 divided by 2, and this is -1. So this is also going to give us -1, the same thing again. So this is also -1. So now we see that yes, indeed, this limit exists. So thus limit x approaching -1 exists, since the left of -1 is the same as the right of -1. Good. So now the next question comes in play. Since we are talking about continuity, then the question is asking, is f continuous at x equal to -1? Yeah, so now continuity, we can see that we've satisfied this. This exists and we are happy. But we need to also check if this one exists. So this means that plug in s is equal to a inside this. So we need to find f of what is here. We need to assume that x is equal to -1 and plug it in. So plug it in minus this and it's equal to, so what is f of x? So let me do it up here. So this is f of -1. Now one thing about this is, anytime you are dealing with this, you don't simplify. Like for example, the one that we're doing here, because it was a limit, we need to simplify. But when we are doing direct substitution, we don't simplify, because we know that we can simplify and cancel out, but here we don't simplify. So this one will be -1 squared minus 1 divided by -2 times -1 plus 2. So this is going to be 1 minus 1 divided by -2 minus 2, and this will be 0 divided by 0, which is indeterminate, right? This is indeterminate. So we can see that f of -1 does not exist. So hence we can conclude that hence, or let's say thus f is not continuous at x is equal to -1, since f of -1 does not exist. Good. So let's assume that this one was in existence. Then when we need to compare now to this and see if they are all getting 1 before we can say that, okay, indeed, it's true, it exists. So this is continuity. Like basically, this is some of the things that we just need to do. Let's look at this one too. We want to find limit as x is approaching 0. So as I said, still for us to talk about 0, those kind of things, we need to think about left and right. So let's think about left and right. Limit x is approaching 0 from the left of f of x. What do we get? What is the function for limit x is approaching 0? Meaning that 0x is less than 0, this and that. So we have sine x, and then we set x to be equal to 0. So we are going to have sine 0, and sine 0 is 0. Is that true? Yes, sine 0 is 0. Then let's look at the right side. Limit x is approaching 0 from the positive of f of x. This is limit x is approaching. So this means that x should be greater than 0. So x is greater than 0 is here. So we are using x squared. So x squared and plug in x is equal to 0, and this will be 0 squared, and this is 0. So indeed, this is equal to 0 because the left and the right is the same. Let's look at this one too. For this one too, for us to conclude, what we need is we need to look at limit x is approaching 2 pi from the left of f of x, and also look at limit x is approaching 2 pi from the positive of f of x. So limit x is approaching 2 pi from the left. What function do we need to use? From the left means that x should be less than 2 pi, which is here. So we are using x squared from there. So x squared. Here we are setting x to be equal to 2 pi. So this is 2 pi squared, and this is going to give us 4 pi squared. The reason is that the minus here is just showing us the direction. And then this is going to give us limit x is approaching 2 pi from the positive. What's the function? It means that x should be greater than 2 pi, and we are going to have this. So we are going to have 2 plus cos x. Set x is equal to 2 pi. We have 2 plus cos 2 pi. What is cos 2 pi? Cos 2 pi is, I think, cos 0 is 1. Cos 2 pi should be 1. So this is going to give us 2 plus 1, and this is going to give us 3. So we can see that this is not the same as this. So we can conclude that this does not exist. Good. So the next question comes in play. Is f continuous at s is equal to 0 and s is equal to 2 pi? Here we can even conclude from here that it is not true. So now with the first question, since this is equal to 0, now what we need to do is, for us to conclude, we've now satisfied one condition, that limit as x is approaching 0 of f of x was equal to 0. So one condition is satisfied. We need to look at the other condition too. F of 0. Is f of 0, what is f of 0? Let's go and check from the diagram. F of 0 here, this one means that, this one that we are writing here means that x is equal to 0. So when you look at s is equal to 0, the function here is 1. And this is equal to 1. And this also exists. But the last condition is not permitting us, because now limit as x is approaching 0 of f of x is not the same as f of 0. So this is not continuous. So s is equal to 0 is not continuous, or you can say that f is not continuous. F is not continuous at s is equal to 0. Then the last one, we can also see that even the function itself does not exist. So we can say that f is not continuous at s is equal to 2 pi, since the limit as x is approaching 2 pi of f of x does not exist. Good. So these are some of the things that you need to be doing when we are dealing with continuity. Let's take more examples. Let's take 2 or 3 examples in addition, and then I'll give you a trial question. Good. I love this question a lot. This, we want to find a constant here such that the function is continuous. So this is one thing that you need to also have in mind. Anytime the question says that the function is continuous, it means that all this condition is satisfied. So you can use any of them to work. So now, since this is saying that we should find C such that this is continuous, then the condition works. But I will show you the trick that you need to learn from here. Always, if a question is putting in this form, you need to look at what is here and pick which one are you going to use. Now, anytime I have something like this and it's going with not equal to and equal to, then I need to pick one of the condition. And which condition are we going to pick? We are going to pick this condition here, this condition. So have in mind, anytime you are solving and you have something like this is the condition that we need to use. This, only this, because now the function is continuous. So this is true, this one is also true. So we can pick one of them to solve. So we are using the idea that the function is continuous. So since the function is continuous, we are using idea that limit as s is approaching a of f of x is the same as f of a. That's the idea that we want to use. Now, the limit here is the one that goes with x is not equal to 0. And then this one is the one that goes with x is equal to 0. So that's what you need to know. This goes with the one which is not equal to 0, and this goes with the one which is equal to 0. So let's solve them and see. So I pick the first one. So first one, I'll pick limit as s is approaching 0, because this is what we are using. X can never be 0. So x should be approaching 0. And then the function f of x is this here, this one. So I'm going to have x squared minus 1 divided by x minus 1. Since its limit, okay, this is 1. Okay, so I think I made a mistake here. This is supposed to be 1 because I'm talking about 1 continuous at 1. So this should be 1. So not continuous at this, and this one should be 1. Sorry. Good. So now plug in 1 here, and this 1 becomes 0. So we need to simplify. Simplify the top, x minus 1, x plus 1, difference of 2 squares, and x minus 1. And this cancel this, so we are going to have limit x approaching 0 of x plus 1, 1. And this is 1 plus 1, and this is equal to 2. So we are done with this side, right? We need to now look for this side. So this side is when we are looking for f of a, which is f of 1. So what is f of 1? F of 1 is when x is equal to 1 and is equal to c. So this is c. So now we can say that since the function is continuous, then limit as s is approaching 1 of f of x should be the same as f of 1. So that's the reason why we said we need to use this. And pay attention, as I said, always when you see this is equal to or not equal to, this is what we need to use. So now what is this? What do we get for this? We had this to be equal to 2, and we had f of 1 to be equal to c. So it means that this is 2, which is equal to c. So this implies that c should be equal to 2. So it means that when this c here is 2, the function becomes continuous. So like now our piecewise function will be something like this. X squared minus 1 divided by x minus 1, 2, x is not equal to 1, and x is equal to 1. And this becomes continuous. So that is basically this. Let's pick another one that I will show you different trick. Now, the same thing here, we want to find a such that this limit exists when this is equal to this. So anytime you see something like this, then you ask yourself, which one am I going to use? Which condition? So anytime you see that condition there, we are going to use this one here. So anytime the question is asking you to find something and the function is continuous, it's either you use this or you use this. One of them is the one that you're going to use. So we look at the sign here and we see that this is less than or equal to symbol, not like this. So it means that here we need to use the left and then the right. Good. That is basically what we just need to do here. So if that's the case, then I need to pick limit as x is approaching 1 from the left of f of x, and then I pick from 1. So what's the left? The left is the one x is less than 1. So x is less than 1, I have this one here. So I'm going to have 3x plus 5, and then I set x equal to 1. So I'm going to have 3 times 1 plus 5, and then 3 plus 5 is equal to 8. Then I need to look at the left, so I need to look at the right. From the positive of f of x, limit x approaching 1 from the positive. What function do we need to use? X should be greater than 1. I'm using this. 2x, I'm using 2x plus a. Good. Let's set s equal to 1 and solve. So this is going to be 2 times 1 plus a, and this is 2 plus a. Now we are saying that the function is like this exists. If this exists, it means that the left and the right is the same. Because for us to conclude that this limit exists, as we saw from the rules, this exists, then the left and then the right are the same. So that is what we just need to deal with this one. So we are saying that since limit as x is approaching 1 of f of x exists, this implies that limit as x is approaching 1 from the left of f of x should be the same as limit x approaching 1 from the right of f of x. So what did we get for this? We had 8. So we are going to have something like 8 is equal to, what do we have for this? From the right, we had this. So we are going to have 2 plus a, and a will be equal to 8 minus 2, and this is equal to 6. So basically, that's what you need to do. So pay attention to what is here and the ones that you need to use to solve. So anytime you have something like this, use the idea of the left and then the right, and then you equate them to find a constant. And then when you have something like this, use the last condition that says that limit of this is the same as when you plug it in, and then you use that one to also solve from there. So we are done, and I want to give you a trial question. You see, I'm a very good instructor. Always I give you a question to try so that you can practice, right? So use the same idea here and the same idea here. So pay attention to this one. But this one, it's kind of, you are going to do a lot of work. Let me let you know. This is kind of, you are going to use the left and the right again, but here you are going to have simultaneous equation and you need to solve for A and B. Yeah, so because these are two constants. So basically that's what you just need to do. All right. So basically we are almost finishing limit. So see you in the next video.